Hello, everyone. My name is Yuri Trukin. I am currently working on developing the Cloud MTS cloud platform. A few years ago, my team and I built the first GPU supercomputer in Russia in a public cloud. A few months ago, we made an important update that made it even more accessible for companies of any size. From the smallest startups just beginning to experiment with machine learning to the largest multinational corporations. When developing our services, it is very important to us that technologies which usually cost as much as the Starship Enterprise become more accessible, both for developers and in fact for clients of any scale. And a number of improvements in the service architecture were made precisely for this purpose. Today, we will talk about an important topic, probably the most important one, the very reason all of this was done. In this area, technology enables us to tackle humanity's most important task, preserving and extending life. And artificial intelligence is helping us with this. In this talk, I would like to showcase the tools that form the technological foundation for implementing AI in medicine, as well as AI solutions developed by our clients. Our users are developing and utilizing solutions in these areas, and we hope that more and more organizations in the healthcare sector will follow the technological path of development and improvement. As has been mentioned several times at this conference, artificial intelligence will certainly not replace doctors in the foreseeable future, but it will definitely transform the way they work. It is absolutely clear that specialists do not always make the best decisions. If they had decision support, they could perform even better. The healthcare sector actually generates enormous amounts of information every day. The use of technology to preserve and classify knowledge and to make it more accessible has long been needed by healthcare professionals. After all, we actually have quite a large volume of data. These are data from electronic patient records, X-rays, ECGs, and laboratory tests. All of this can be used to train artificial intelligence algorithms. AI-based decision support is extremely important. Statistical analysis diagnostics, all of this will improve the quality of medical staff's work and, very importantly, reduce the number of errors caused by human factors. After all, medical errors can lead to very tragic consequences. For example, here's a story from the experience of our own client. When analyzing hundreds of images a day, it's easy for specialists to miss a shadow in the lungs due to fatigue. This could be cancer. Without timely treatment, this can be fatal. AI technologies make it possible to automate this process and significantly increase recognition accuracy. What's especially important is that a number of diseases can be treated at early stages. And with the use of AI in bioinformatics, it's even possible to predict future illnesses. When COVID began, finding a vaccine became the #1 priority for many countries. Our GPU supercloud, our new supercomputer, joined the project to find a cure for COVID on a pro bono basis. Moreover, there were times when there were fewer analysis tasks than the available computing power. Deep learning requires critical performance. With the development of the computer industry, a number of obstacles have emerged that hinder further growth in the computing power of central processors. In most server architectures, RAM is located far from the processor and operates at a lower frequency. Further reduction of process technology sizes faces physical limitations. With every doubling of clock speed, heat dissipation increases 16-fold. Therefore, it's unlikely that we'll see frequencies in the tens or hundreds of gigahertz anytime soon. They are critically important for training and developing algorithms. The main driver for performance growth is parallelism. And this is where the graphics processor comes to our aid, consisting of homogeneous computing elements with shared memory and capable of processing thousands of threads simultaneously for a single task with thousands of cores. In fact, a graphics processor is a computing cluster on a microscale. And specialized tensor cores for artificial intelligence further increase the speed of processing operations by up to 30 times and even higher in the latest generation. We use graphics cards in the supercomputer because they are excellent at handling the entire range of tasks required for working with AI. And thanks to the new hyperscalable architecture, its use makes economic sense not only for deep learning, but also for inference. In other words, we have essentially created a unified installation that can be used equally effectively for both deep learning scenarios and inference scenarios. We are able to scale vertically from a low-power graphics card all the way up to one of the most powerful graphics cards in the world. Then, horizontally, we can scale up to massive clusters using the fastest cards connected by a high-speed unlimited 100 gigabit Ethernet network, and very importantly, with low latency and ultra-fast storage. We built the architecture together with market leaders NVIDIA and Mellanox, and thanks to this, we have incorporated global expertise in this area. And by the way, everything shown on this slide is already in production and has been successfully used by hundreds of commercial clients. We took our users' feedback into account when refining the architecture to its current version, which allowed us to simplify supercomputer management and add hyperscalability. And our users have access to familiar tools for working with artificial intelligence, such as containers and the catalog of ready-made solutions and frameworks from NVIDIA Cloud. Based on user feedback, we have also significantly improved the supercomputer's network. Interestingly, the supercomputer allows you to take full advantage of the elastic cloud infrastructure. For example, you can manage it using the infrastructure as code approach, specifically with Terraform and Ansible technologies, or manage it through the VMware graphical interface if needed. And it supports all the features of elastic cloud, such as backup, segmentation into virtual data centers, and smart access management. Fine-grained security settings allow you to connect the customer's local site with the cloud without exposing the service to the internet at all. Because everyone understands that medical data and a huge amount of the data collected is actually a commercial secret, and it simply shouldn't be transmitted over the internet. Of course, if there is any technical question, we provide free support at all levels of the infrastructure, from hardware to the software on top, including specifics like hardware operation and video driver virtualization. In my experience, there have been cases where, thanks to user feedback, the performance of certain deep learning frameworks increased by more than 25%. Accordingly, we have NVIDIA Cloud Provider status. If a problem arises, we can work with vendors on such issues as a priority and achieve the fastest computations this way. And if you look at some theoretical data, in general, a single host installation is about 140 times faster than a CPU host for deep learning tasks. And all these improvements are already available to all users of our service. On the next slide, there's an example of AI implementation using our service. In one of the largest private clinic networks in Russia, even now, they are already using the supercomputer for video analytics in operating rooms and inpatient wards, controlling access to clean zones, routing patients throughout the clinic, performing recognition and analysis of CT scans, and analyzing dental images, helping doctors focus on what matters most. They expect to reduce the time spent on data analysis by up to 40% and to increase recognition quality to over 90%. As an additional pleasant effect, by cutting IT expenses by 40%, the money saved can be spent not directly on IT, but on medical, because everyone understands that under current conditions, having a reserve of ventilators certainly won't hurt. A lot has already been accomplished in AI, but going forward, even more needs to be done. What's important is that all of this is already delivering results. But on the other hand, this is only the first step in a vast journey, essentially the discovery of a new world in information technology as a whole. Minimizing human error, developing new drugs, searching for treatments for deadly and incurable diseases, genetic research, personalized medicine of this may help extend people's lives. And perhaps this is the most important thing that humanity can engage in, because it forms the foundation for all other activities. If you have health problems, if you don't live long, there's little else you'll be able to accomplish. That's why this is extremely important. And right now, there is a significant shortage of AI specialists with domain expertise on the market. Just like developers in general, but AI specialists are extremely rare and there is huge demand for them. So our message is learn AI, try training algorithms on your data, and we'll support you technologically with a computing platform so that together we can make the world a little better for ourselves, our parents, and our children. Thank you, and I'll be happy to answer your question.
Yuri, thank you very much for your presentation. If I may, I have a question. In our projects, we encounter the fact that real clinics still do not have access to computing resources. That is, they have no way to use modern technology. Tell me, in your experience, is there any real obstacle to cloud technologies being, why they aren't being used, or what is the reason they simply don't have this?
There are several factors that hold clinics back in this regard. Some factors can be addressed while others are more difficult to resolve. The solvable ones are, for example, the requirements for clinics regarding the security of medical data processing. We already meet these requirements. And in general, there are no major problems here. All the issues related to connectivity, like accessing the supercomputer without going through the internet, are absolutely solvable. But from my point of view, what's really lacking is not just AI specialists, but AI specialists with domain expertise, with knowledge of medical specifics. Because in reality, it's very, strange to see that my kids, just by using an iPhone or some other devices, are using much more advanced AI technologies than, for example, when I go to the doctor and want to treat a serious illness. And so the development and training of such specialists is very important for our shared future. And then everything will work out.
Thank you very much for your answer and for your presentation once again.